Okay, so we got these ice cream cases running warm. Let's take a look. Alrighty, so if we check, there's no airflow. And if we look at the one next to it, which is not an alarm, there's airflow. So I had them already pull the product. Let's take a look. So you can see the fan is running, but there's no airflow. Solid as a rock, nothing. And if you look at the side of that coil, it looks like more than likely there's some type of icing. Let's see if we can lift it up and get a deeper look. So you can see back there, there's ice buildup on the back. So that tells me that more than likely there's some type of defrost problem or something going on. Where, you know, for instance, if there's ice buildup from the floor and it wasn't snowy and it was like a solid looking ice, that might tell me it's a drain problem. We're gonna have to pull all this and move forward. Alright, I got the manager to pull the product, and while they're doing that, I just kind of come up here and I go, you know, it's Racky ice cream. That one ice cream case is 38. Let's see. The pressure is targeting is right. I go down, one, and the condensing pressure looks fine too. Now I'm going to physically go over and look at it. So here's the little fella right over here. Just this one compressor right here. Now you can see how this is all frozen up. Now, a lot of people might think there's like a flood back issue. And there's probably liquid refrigerant flooding back because the coil is iced up, so it can't absorb enough heat to work properly. So, and I just want to check in there and make sure that the Defrost controller is working properly, or at least is on. So, just giving a quick look in here, making sure there's nothing else special in there, any boards, anything. Alrighty, so now I'm going to get my tools, de-ice it, and then we're going to try to figure out why it's icing up. Also, if you want, you can check your sight glass and your receiver level if it has it on it. And everything here seems fine. So, like I said, I'm going to go grab my tools, de-ice it, and then we can dig into it further. Again, this is just what I do, but you want to set up your perimeter so nobody walks in and slips on water and then dies, and then someone sues you and then you lose your job, and you know, and all that good stuff. Okay, so I removed everything, put them in shopping carts over there. Okay, now just looking in here to see, you can see there's a thick, like, ice, almost like, you know, 1, 2, 3, like, in that middle, you know, back third, it's like iced up. If you look down there, it's kind of worse, okay? I turned off the fan so I can move off this, you know, cover to it. And so now what we're gonna do is we're gonna manually turn on the electric defrost, and we're gonna see. Now, also, just here's a quick tip. You can see if you follow the wires, where do they go? To the back wall. Okay, they don't go this way. They don't go in here or underneath or something like that. And that's just a principle. Just see where they go, and that's probably where they're located. So there's a bunch of wires in the back wall underneath that panel. We might go and dig in there if we need to, but right now we're just gonna test the defrost. Now, of course, I'm always concerned, you know, you guys, if you watch my videos from whatever, you guys always know I almost always start off with like a brain, or like, you know, what's going on at the headquarters, you know. So what we're gonna do is we're gonna turn on defrost, but we're also gonna look, so I'm gonna go to network nodes, and then we're gonna go to points, relays, and we're gonna see what board and point is even responsible for, and make sure that board and point is sending the signal for it to work, and that the defrost contactor is pulled in as well. So we're going to look for case E defrost, and we're going to turn it on. Right there, E1 refrigeration, electric defrost. So we're going to go into there, we're going to turn relay, operation, manual on, okay? And we're going to see this as board and point 05-1.2. I'm actually not going to manual on this because I don't want to forget to take out an override. And when you manually on it that way, it'll permanently stay unless you take it out. So I'm actually just going to go to the case itself, going to go to service. I'm going to go down to defrost, operation, manual on. That will automatically take itself out of 60 minutes, so kind of like a safeguard for my own human stupidity. So you can see I'm checking the Defrost board, right? So that's 5-1 and number 2. I'm checking the difference of voltage between the common and normally open, which is you know, 1 or 0 basically. So what that is telling me is that from this common, the relay in there has activated, sending signal along this normally open line. So we're going to follow this down and see where it ends up. We'll actually see that this goes to the bottom of this contactor right there. And if we check our voltage across, we have voltage on the line side right here going out to our cases. So it seems like our electric defrost, as far as calling for it and being sent to our case, is working. So now we'll check it down there, as well as de-ice the case and do all that stuff. So there's two theories right now I have. Is one is two fans were not working, so it could be an airflow issue, and number two is that one of those heaters are not working. So first off, I don't think this heater's not working, but let's just test it with the temp gun and let's just kind of like give a reference with it. So you know, it's like 5 degrees, so that makes sense. We'll come down over here and we'll actually, wow, you know, 200 degrees. Okay, that's hot. Okay, we're gonna go to this one over here. You know, 200 degrees is pretty good. And we're gonna go to that last one, which again is still 200 degrees. So it might be actually that these cases over there are shut down, and it might actually be moisture coming in from there and caking in there, you know, accompanied with the fact that we got 2 fans down. So, but we're gonna take some amp draws and keep going forward. This case is easy. This is a Hill Phoenix case. So if we look up here, volts, see defrost heaters if provided, 208, that's what we have. 13.81, 3-phase, that's what the amperage seems to be corresponding with that. So let's take a look, see if it works. All right, so just to show you here, I'll show you. So we have right here 5.6, here we have 5, 4.9, and over here we'll have 5.8. So basically we have about 16 amps total being drawn. So if we were to take, let's say 14 and divide it by 3, okay, we would get 4.666666, right? So what this is saying is, with that nameplate up there, is that on average each one of these heaters altogether will pull 13.833 or whatever it was. So you know, rounding it up to 14ish, it's going to be about 4.6 each. These are all about an amp over. The middle one is perfect, and that just has to probably do with conditions that they're under, age, manufacturing differences. Also remember, there was a range up here for 208 to 240. No utility company is perfect, so you could be having cycles of 215 instead of 208, or 220 instead of 240, just because of utility, and this is kind of in a remote area. So it checks out to me. They're all within 1 amp of what they're supposed to be, and if you're really finicky on it, you could go over there and test over there as well. I also test, to the best of my ability, I'll actually test the opposite side of the heater as well, if I can see it, kind of see right there, 300 degrees, because if there might be a break or something that might be preventing it. Granted, it shouldn't really be pulling amps correctly if that was the case, but I guess my philosophy is, you know, you never be too careful. You know, these are just kind of, you know, resistance heaters. So yeah, it's 339. So you know, they're not like perfect. You just want to kind of, you know, test it the best you can. Just want to reiterate, this value is the total current by all 3 all 3 heaters. Okay. So just want to reiterate, total value. Hussmann has done the same thing with their heaters, but sometimes they'll differentiate their drain pan. It just depends on your case. So I just wanted to reiterate that. Kind of confusing, kind of silly, if I'm honest, but hey. So just wanted to show you, we're building a case now. So rooftop, you know, this is left rear sales floor, humidity 53.9. So that's really high. Typically speaking, you know, I mean that's not crazy high, but that's not the best for sure. I'm actually gonna see if I can maybe even, you know, stage this humidity to a lower amount if possible. But basically, you know, your max operating conditions for a lot of these systems are 55, 75. So, you know, if this thing is maxed out all the time on humidity, and now the cases next door to it aren't working, and it's just pumping in warm, humid air, I mean, I could see that causing this. Also, some of the fans were out. So, you know, we're just kind of building what could happen, because the defrost heaters are working, the drain pan's working. So now we have to try to figure out, is there anything that could have done it? It could even be the rate that's feeding refrigerant. If it's flashing off too quick and not making it to the end of the coil, could possibly be causing some type of issue. So anyway, we're just going to keep going. Kind of show you some of what I'm talking about. This case over here is like 80 degrees. Nothing's going on in it, all right? So then this has a very blatant access point right here where it's just kind of pouring in the 80-degree air right into there. So again, now we can look and see that this drain's clogged. So the reason why I mention this is, like, we're just kind of building a case here because there's no smoking gun, there's no defrost heater that's not working, or drain pan that's not working. Everything seems fine, but it's iced up for some reason. So now we're like, okay, let's see if there is anything we can address that might prevent this in the future. Anyway, as you can see, so we cleared the coil and everything. I replaced the center fan. It needed to be replaced. The mounting wasn't the same, so I had to do a whole assembly. So what do we know so far? The drain pan, the heaters are fine. The heater for the pipe is fine as well. The humidity in the store is a little bit high. This fan was out. That fan down there is actually okay. It was just, I think, a little bit loose. So I think we can safely conclude that the humidity of the store caused this. It always happens this time of year. So this store is actually on the ocean. So I might just have to talk to my boss about maybe just, you know, getting here, trying to get the HVAC system working better. Because a lot of refrigeration techs don't understand that if your HVAC is not working, your refrigeration is going to suffer as well. So, like, these cases are older. They're old Hill Phoenix cases. The system, as you saw, is older. It's just not built for this level of wear and tear, especially this place is like a mile or two from the ocean. So it's, you know, kind of suffers from high humidity. So anyway, I thought maybe I'll just post this. So yeah, please like, subscribe. Maybe you'll learn something. Maybe you didn't. I don't know. But that's how you troubleshoot it. That's how you do it. I wanted to post more of these electric defrost scenarios because troubleshooting electric defrost system can be kind of, you know, you know, like intimidating at first. So anyway, we checked the board, giving the signal. We checked the contactor pulled in. We checked down here. All the defrosted works. We checked the amp drop. All the amp drop worked. We checked the heater inside the drain line. The heater inside the drain line worked. So all of that. There's a fan out. We checked the humidity in the store. High humidity. So I'm going to say that that's more than likely it. I might check superheat across the coil to make sure it's not starving the coil or something like that. But I think that this is good for this video. Decent troubleshooting video for it. Hope somebody learned something. That's how you do it. So I actually found the real thing. I thought this was actually kind of interesting. Is you see the red wire right there? So I don't know why they would possess them to do it. And it goes all the way over there, you see, right? The reason why this thing actually, I want to unplug this one right here, is if you see when I unplug that one, now the rest of them are running better, okay? The reason that I stopped is somebody actually, it's actually pretty wild, I can't even believe it. They actually strung that red one all the way over here, okay, to this case, and they basically, like, my theory is the clicks on was bad, so they thought the best course of action was to make this monstrosity here and tie it into the clicks on way over there and siphon the power off of this one. So now you got, like, you know, instead of 5 fans in a series, we now have 20 fans in a series, and all the fans are running much slower because when you put things in a series, you build up a higher resistance value. So now we have a bunch of fans running in series that are running slower than they should be, which is going to cause less airflow, which is causing icing up. So anyway, I just thought I would kind of share that. That's why you don't do work like this. You just don't do it. All right, so I just wanted to show you. I think I actually found the elephant that kind of figures out what it is. So if we look at, someone kind of jumped power, one leg of power, that red wire, all the way over to these fans over here. So I noticed this because when those fans were running, they were running great. And then when these ones started up, all the fans started running like half speed. So it seems to me that someone, for some reason, jumped power over. I don't really know why, and now it's causing all the fans to run at a reduced capacity. So that gives us a reduced airflow, which will eventually build up ice over time, and that kind of indicates why it built up ice only in that one kind of section of the coil. So for instance, that back heater was still heating up that back portion, the front heater was heating up the front portion, the airflow was getting, you know, 2/3 of the way through, and that's why you kind of had it in this awkward like 3/4 of the way through type of area. At least that makes sense to me. So anyway, I figured that was worth doing it. I'll post it, you know, hopefully you'll. So I guess thought I would show you, I guess after some digging, oh boy, right, I found that goes out through that back hole, comes down to the bottom, and then I looked up the wiring diagram, and I found that the things responsible for the fans are number 4 and number 3, okay? Now number 3 was actually just attached hanging here, and then, you know, number 4 was obviously attached correctly. So all I did was I wired in number 3 with there, and now the power will work with those fans. So that's what I ended up having to do. So I cleaned this up, cut that whole wire all the way down there, and then I also rehooked it up over here. So now it's actually working over here at the right speed and everything. So yeah, I'm just gonna put it back together, and you know, just, I'm sure it'll pull tap now. So anyway, I'd show you. So I just downloaded this Phoenix company, you know, ORZ. That's just the name on the nameplate. You know, I'm gonna go down a little bit, basically till the end. I'm gonna go down quite a lot, and we're gonna find these Phoenix things. You know, I didn't actually use a wiring diagram. It has a wiring table. And I found that if you look at the wiring table, it has primary fans right there, right? And I went over to here, and then I found the primary fans were 4, 3, white, black, and then this one over here is for L3 is 40. But I know that on the nameplate, I'll show you the nameplate. You see on the nameplate, it says that the fan's 120. So to me, that automatically kind of, you know, exits out that whole, you know, blue possibility. So I went down there, found that 3 was loose, connected it. Now that plug works over there. The fans now worked. I just got to hook it all back up together. So kind of a doozy today, I guess. You know, maybe you learned something today, maybe you didn't. I don't know. Please like, subscribe, and all that. And yeah, thanks for watching. That's how you do it.